Hi students, today we are going to discuss the method of differences for finding the nth term of a given sequence. If the given sequence is in the form of AP or GP, you can find easily the nth term by using the respective formulae. But whenever the given sequence is in the form of so this is, let us take T1, T2, T3, T4 like that Tn. Let us calculate the first differences like T2 minus T1, T3 minus T2, T4 minus T3, like that Tn minus Tn minus 1. If this is constant, all these values are constant, we can say directly it is a arithmetic progression. It is a arithmetic progression. And but if they are not constants, let us represent it with these are nothing but the first differences. These are nothing but the first differences. Next, again you subtract. For example, I am representing it with D1, D2, D3, like that. This will become Dn minus 1. Now, again you find the differences. That means difference between D1 and D2. And similarly D2 and D3. That is D2 minus D1, D3 minus D2, like that. We are going to get. So these second differences, these are called as the second differences. If the second differences are constant, then it is called as a quadratic sequence. It is called as a quadratic sequence. So when we can call the given sequence as quadratic sequence, if the second differences are constant, if the first differences are constant, directly we can call it as arithmetic progression only. But if the second differences are constant, then it is called as the quadratic sequence. And for a quadratic sequence, nth term is in the form of a quadratic expression form like an square plus bn plus c, and you have to find the values of a, b, c. So many ways are there for finding the variables a, b and c. And similarly, suppose if the second differences are also not constant, let us represent these second differences with delta 1, delta 2, delta 3, like that. So that means these second differences I am representing with delta 1, delta 2, delta 3. Again you calculate the differences like delta 2 minus delta 1, delta 3 minus delta 2. If these are constants, that means these are nothing but actually now it will become third differences, isn't it? Why? Because again we are calculating the differences, means these are nothing but the third differences. So whenever third differences are constant, if the third differences is constant, then that sequence is given as a cubic sequence. That sequence is called as cubic sequence, and for this cubic sequence, nth term is given by an cube plus bn square plus cn plus d. So like that, we can find the nth term by using the method of differences, okay, for a given sequence. So let us take an example and let us discuss how to find. Right. Now I am considering a sequence 1, 3, 8, 16, 27, 41, so on. Let us try to find the differences. What are the difference between 1 and 3? The difference between 1 and 3 is 2. 3 and 5 is 5. 16 minus 8, 8. 27 minus 16, 11. And 41 minus 27 is 14. Whether it is a constant? No. If it is a constant, automatically it will become AP only, isn't it? If all these differences are constant, then it will become AP only. But here, the differences are not the constants. That's why I told you already, these are nothing but the first differences. Now calculate the second differences. Second differences means 5 minus 2, 3. 8 minus 5, 3. 11 minus 8, 3. 14 minus 11, 3. That means second differences are constant here. Understood or not? So second differences are constant. Here first differences are not constant. Their second differences are constant. Whenever second differences are constant, I told you already that sequence is called as the quadratic sequence. It is called as a quadratic sequence, and nth term will be, so this is a quadratic. Second difference is constant, that is 3. So this is a quadratic sequence. So already I told you nth term is equal to an square plus bn plus c. So to get the ABC values, we can go by two methods. First I will give one method, first method, that is the general method. The general method is by taking n is equal to 1. So put n is equal to 1, we have to get the first term. What is the first term? That is 1. That means a plus b plus c is equal to 1. Put n is equal to 2. So if you substitute n is equal to 2, 2 square, that is 4a plus 2b plus c is equal to, in the given sequence, what is the second term? 3. And similarly put n is equal to 3. Why? Because we need at least 3 equations to get the values of a, b, c. So this is 3 square, that is 9a plus 3b plus c is equal to 8. Now I am taking, this is first equation, second equation, third equation. We have to solve these 3 equations to get the values of a, b and c. Now second equation minus first equation will give us, second equation minus first equation, 4a minus a, that is nothing but 3a, 2b minus b plus b plus c minus c gets cancelled. We are going to get 3a plus b is equal to 2. Take this as fourth equation. And similarly now I am taking third equation minus second equation, 9a minus 4a, 5a, 3b minus 2b plus b, c minus c is cancelled and you are going to get 5 here. 8 minus 3 is 5. This is fifth equation. So solving 4 and 5, solving 4 and 5, we are going to get, that means fifth equation minus fourth equation, fifth equation minus fourth equation, 5a minus 3a, 2a is equal to 5 minus 2, 3, which implies a is equal to 3 by 2. Once we got a value from fourth equation, we can find b value. B is equal to 2 minus 3a, 2 minus 3 of 3 by 2, which is nothing but minus 5 by 2. 2 into 2, 4 minus 9, minus 5 by 2. We got a value and b value. Let us substitute from first equation, we'll get c value. That is c is equal to 1 minus a minus b, that is nothing but 1 minus 3 by 2 plus 5 by 2. We are going to get 4 by 2. If you take LCM, 2 minus 3 plus 5, 4 by 2, we are going to get c value as 2. So this implies c is equal to 2. Finally, nth term can be written as, nth term is equal to 3 by 2 n square minus 5 by 2 n plus 2. So this will become the nth term of the given series, that is 3 by 2 n square minus 5 by 2 n plus 2. After getting the nth term, you can check whether your answer is correct or not. By substituting n is equal to 1, you have to get 1. And by substituting n is equal to 2, you have to get 3. By substituting n is equal to 3, we have to get 8. Like that you can check it whether it is correct or not. So this is the method you have to follow for finding the nth term of a quadratic sequence. Okay. Now let us see the shortcut method for this. Right. Right, students. Now what I am going to do is consider a sequence 3, 7, 13, 21, 31, 43. So now I told you already, let us try to do this by using some shortcut method for finding the ABC values. That is, general method is correct only, but even though I am going to take the shortcut method also for finding ABC values for a quadratic sequence. Now I told you already, first let us find the differences. What is the difference? 3 plus 3, 7 minus 3 is 4, 13 minus 7, 6, 21 minus 13, 8, 31 minus 10, 21, 10, 43 minus 11, 31, that is nothing but 12. So these are the first differences. These are the first differences. First differences are not constant, so that's why it's not an AP. Now let us go for the second differences. What is the second difference? 2. 8 minus 6 is also 2. 10 minus 8 is also 2. 12 minus 10 is also 2. That means second differences are constant. Second difference are constant. So that's why nth term is, you can take nth term as an square plus bn plus c, since this is a quadratic sequence. Now I want to find the a value easily, by taking this last difference constant is there now, that value you have to take it as 2a. That means what is the common difference we got? The constant difference, that is the second differences are constant, we discussed already. This value we got 2 now. This value has to be taken as 2a. That means 2a is equal to 2, which implies a is equal to 1. We got directly a value. We got directly a value here. So whatever the constant difference we got, that constant has to be considered as 2a. That's why a is equal to 1. Now consider our sequence. What is the sequence given? 3, 7, 13, 21, 31, 43, so on. Now write the n square values. That is an square. So 1 and it's 7 minus 4. N square value I am writing 1, 4, 9 and this is 16. So n square value if you write 1, 4, 9, 16, 25, 36. Now find the differences. What is the difference? 3 minus 1 is 2, 7 minus 4 is 3, 13 minus 9 is 4, 5, 6. So again they are in AP. Directly you can say 2, 3, 4, 5, 6 are in AP. So find the nth term of this one. So what is the nth term for this? Nth term is equal to a plus n minus 1 into d, which is nothing but 2 plus n minus 1 into common difference of this series is nothing but 1. That means 2 plus n minus 1, we are going to get n plus 1 directly. Now already we got n square coefficient. So an square, this will become bn plus c now. This will become bn plus c now. So that is an square is n square plus bn plus c is n plus 1. So this is the shortcut formula for finding the nth term of a quadratic sequence. So previously I have given the general method and this is the shortcut method for finding the nth term of a quadratic sequence. Okay, right, all the best.